Hi everyone. For this video, we're going to talk about hyperbola, which is still part of our conic section topic. A hyperbola is a curve on a plane defined by the set of points for which the difference in distances from two fixed points called foci is constant. And the difference of this is always greater than 0. The shape of a hyperbola resembles two mirror image curves, just like the yellow curves that you can see on your screen. And they each extends infinitely away from a central point. So hyperbolas have two branches that open in opposite direction. So one hyperbola can be we call that as horizontal hyperbola, where they open left and right, whereas we have a vertical hyperbola that opens upward and downward. And the distance between the foci is the key parameter that determines the size and orientation of the hyperbola. So I've mentioned foci, I've mentioned fixed points that should be constant. So let's identify the key components of hyperbola. Let's start with the vertex. Just like parabolas, each of the pieces has a vertex. So the curves has a vertex. So this one is one vertex. This is the second one. For vertical hyperbola, so this is the vertex and this is the other vertex. Then a hyperbola has two foci, just like a parabola, which we can find inside the curve. So this is one focus and this is the other focus. So same thing here. That's the first focus and this is the second one. For the axis of symmetry, it is the line that goes through each focus. So for a horizontal hyperbola, the axis of symmetry is parallel to the x-axis, whereas the vertical hyperbola, the axis of symmetry is parallel to the y-axis. There are also two lines on each graph. So let's start with the horizontal parabola. These red dotted lines, these ones are called asymptotes. And as the graph shows, as we make the x larger, like, going to the positive side and this going to the negative sides, the graph of the hyperbola gets closer and closer to the asymptotes. The asymptotes are not officially part of the graph. However, they are included so that we can, make sure and get the sketch correct. The point where the two asymptotes cross is called the center. So this is the intersection of the two asymptotes. So this is the center of the hyperbola. So for vertical hyperbola, this is where the two asymptotes intersect, and that is what we call the center of the hyperbola. The letter A denoted on this graph is the distance from the vertex to the center. So that's A, and the opposite would be negative A. And same thing with the vertical one. So this is also A. And this is A, center to the vertex. For the parabola that opens left and right, the standard equation that will follow is x squared over a squared minus y squared over b squared equals 1. And for the hyperbola that opens up and down, the standard equation would be y squared over a squared minus x squared over b squared equals 1. So when do we know which is which? So if the x squared is positive, if your x squared is positive, then your hyperbola opens left and right. If your x squared is negative, or if the y squared is positive, then the hyperbola opens up and down. So let's go to this horizontal hyperbola. So the vertex, or the vertices, the coordinates of the vertices will be plus and minus a and 0. This is where the center is at the origin. Okay? So for the vertical hyperbola, the vertices, or the coordinates of the vertices, would be 0 plus or minus a. Now for the distance between the center and the foci is what we will denote as the C. So center to the foci is C. So it is true with the other one, the vertical. So this is center to foci C. So that's also C. So from between two foci, we have 2C as the distance. So the coordinates of the foci for the horizontal hyperbola would be plus or minus C and 0. And for the vertical hyperbola would be 0 plus or minus C. The distance between the foci and the center, which is denoted by C, is related to the constants a and b by the equation c squared is equal to a squared plus b squared. So if you're given a and b, we can solve for c. Okay, so now let's define the equation of the asymptotes. So for a horizontal hyperbola, the equation of the asymptote would be y is equal to plus or minus b over a x. And for the vertical hyperbola, the equation of the asymptotes would be y equals plus or minus a over b x. Please remember that the equations of the asymptotes, the coordinates of the vertices and the foci, these are only true for center 0, 0 or at the origin. So if the center is at HK, then everything will be different. So for the horizontal hyperbola with center HK, the standard equation would change to x minus h squared over a squared minus y minus k squared over b squared equals 1. So the quantity x minus h is still the positive. Now for the vertical hyperbola, the equation would be y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, let me rewrite this equation here on top. Okay, there you go. So now let's go to the coordinates of the vertices. So in this case, where the center is at hk, we just need to add the h to the a. So it will be h plus or minus a and then k. And for the foci, it would be h plus or minus c and then k. And the equation for the asymptote would be y minus k is equal to plus or minus b over a times x minus h. Now for the vertical hyperbola, the vertices of, the coordinates of the vertices would be h, and then you add a or k to the a. So k plus or minus a. And for the foci, the coordinates would be h, k plus or minus c. And the equation of the asymptotes for the vertical hyperbola would be y minus k is equal to plus or minus a over b, the slope, x times x minus h. So go ahead to pause this video to take a screenshot of this screen or copy the notes so that you can refer to those notes later on as we solve some problems about hyperbolas with the next video. Thank you.